Integer versus non-integer. Integer is any number without a decimal or fraction. Now, integers can be 0, they can be negative, they can be positive. What they can't have is any sort of decimal or fraction. So these are integers, and these are not integers. Right? Here's a decimal. This one is a fraction. Again, notice it doesn't matter if it's positive or negative. What matters is that there's a decimal or fraction involved, right? Pi is definitely not an integer. Anytime there's a decimal or fraction, it's not an integer. Rational versus non-rational. In this relationship, irrational. This is a little bit more complicated of a topic, but usually it's tested with square roots. And so we're just going to focus for our final review on square roots, and that's what you'll see on your final. So rational numbers are square roots that actually equal whole numbers. So for example, the square root of 25. This is actually just the number 5. Square root of 16. This is the number 4. These are rational. Now, irrational numbers are square roots that do not equal whole numbers. And you can actually check these by putting them in your calculator. And if you enter a square root like the square root of 10, which does not have a square root, that's a whole number. If you enter in your calculator, you'll see it's a decimal that goes on, it doesn't repeat. These are irrational numbers, right? Square root of 10, square root of 2, square root of 47, anything that doesn't equal a whole number. Those are irrational. Now, you're also going to see on the final an expression like root 25 plus root 2, where 2 square roots are added. In order for an expression like this to be rational, both numbers must be rational. So this expression would be irrational because even though 25 is rational, 2 is not. So the whole thing would be irrational. Over here, the thing about solving equations is you have to just know how to do it. There's not like a piece of information I could give you that would really help you. But sometimes it is helpful to have an example. So I've included a lot of the skills we've talked about all in one equation. And so I would encourage you to pause the video and start this process and solve it yourself. But I'm just going to solve this equation, and then you can have it to study and to see all the different things you have to think about when you're solving. So on the left side, I notice there are like terms. So 3 and negative 6 are like terms. 15 and negative 2 are like terms. So 3 minus 6 is negative 3x. 15 minus 2 is positive 13. On this side, I'm going to use the distributive property to get rid of this parentheses. 4 times 2x is 8x, and 4 times 5 is 20, and it's 4 times negative 5, so it's negative 20. Next, I need all the variables on one side. So I'm going to put all the variables on the right side, and the reason is because I like to add, right? This is a negative. I like to just, if I add 3x to both sides, I'll have more positive numbers and less negative numbers, so that's always nice. But you could have, it would have been just as correct to subtract 8x from both sides. But either way, I need to look at both sides and figure out, okay, one of these sides has to have the variables and the other side has to have no variables. 8 plus 3 is 11. Now, here's my variable. I need it by itself. So I'm going to start by getting rid of this 20 and then the 11. 13 plus 20. And then when I divide by 11, I get 3 equals x. Here we go.